Hey guys, when I last left off, had you working through these couple of problems here on part 3, chapter 3. I'm going to show you the solutions to this and kind of go through it real quick. We did A to get 2 together already. Score is less than 45. I figured out where 50 is, so 45 is less than 1 standard deviation. It's right here. It should be between 0 and -1, and it was. Found that on the Z table, came out to this, which as a percent is 37.07. So the ones that are more than would be this area here. Of course, that's 62.93 by subtracting 1 minus that. Number 4, very similar type of question here, except for look what it says. Have more than 70 points. So I shaded incorrectly. Actually, when I did this problem, it should have been shaded over here in the red. Draw and shade it, which there it is. The Z-score is 1.33. That's for this and below. So when you look that up, of course you get this, but the answer to the original question, which is, you know, this little part right here, is going to be 100 minus that, because that's the part above it. Okay, I kind of set up this problem for you as well, and gave you a few of these in terms of what you had to do here. You can see what it was, again, between negative 0.67 and 0.33 was about right there. Of course, I could just use the numbers. 40 would go there and 55 would go there. Either way, I can graph those, see that shading in between it, because that's where it says between, and then subtract them to get our answer. Okay, next page. Okay, talks about how in soccer games, and it's telling us that the mean is 4.3 and the standard deviation is 1.2. Then it kind of goes through again some more answers here. Same type of problems, less than 6, so we plotted 6, found the z-score, found the percentage, and then found what would be over that, right? Not very many games that had over 6 scores. Okay. Let's see, total score is less than 4.5. Well, that was right next to the mean, so of course that value would be pretty close to 0. Looked it up, and it'd be a little over 50%. Again, makes sense. All these things, and then 100 minus that to get there. Number 4 here, more than 7 points. Again, I shaded it wrong the first time I did it and realized it should be shaded over here. More than that, again, the answer to the question is just that little percent way over here, right? And very similar to the other problem, excuse me, on the other page. 4 and 5.5, easy enough. Shade in between, found the z-scores, found the percents, subtracted them, got my answer. Okay. Alright, so let's move on to today's notes. And today's notes, there's something, if we just do this one easy thing, everything else becomes easy from here. I'm even going to try and zoom this in a little bit so you can see this. Okay. Alright, so we know on this curve that 50% falls in the middle, of course, because it's reflective. Okay. Now, what we also know is that within the reds, that is 68%. So we know that when I split this in half, I get 34 here and 34 here. Now, with that being said, that means that if I go backwards here, we knew that there was, well, there's 16 left over here because 68 split 32 in half. I get 16% over here and 16% over here. So this way is another 16%. Okay, so I'm actually going to write that 16%. Okay. And then if I do 2 standard deviations, we said that that was within 95%. And 95% split in half is 47.5. And so up to this point, there was only, if you remember on this graph, 2.5% here, and then 2.5% on the other side. We'll get to that. And the last one is 99.7%. Okay. And so we said that that meant this was leftover is 0.3 divided into 2, that this is 0.15. I'm going to apologize for my little line over here. I made a mistake trying to equal it out. And another 0.15 over here. Okay, so what this really means is from here over is the first 0.15%. Right? From here over is 2.5%. From here over is 16% of the graph. From here over it's 50% of the graph. Well, then how can I get the next number? Right? If I think about the next number, well, it had to be another 34 away. So of course this is 84% of the total graph from here that way is from 1 standard deviation down. Right? So on the same token, remember how we could add 47.5 we can do that to that 50 as well. 47.5 added to that, I get 97.5% of the graph falls within 2 standard deviations and down. And then if the rest of this is 0.15, then backwards to here would be 99.85%. Right? I mean, that's a lot. Of course, then you got the whole graph over here. But we're not going to worry about that. We're going to worry about where everything falls inside of this. And so again, if I wanted to say 97.5% are 2 standard deviations positive or lower, right? And so on. So let's just look at what I'm trying to do here in the notes. So in other words, I'm going to zoom this back out a little bit. We're going to use the z-table, okay, to find the value of z of a standard normal variation that satisfies each of the following conditions. We're going to sketch it, okay, and see kind of what it means too. Like, where would I normally sketch 70%? Okay, well, if I look at this, 84% is here, 70% is, or 50% is here, so 70% is going to be somewhere here inside of 1 standard deviation, right? So, as I graph that, okay, and I think about, here's the mean, right? Here's 1, 2, 3, 1, 2, 3. Okay, the mean is just 0. 1 standard deviation we said was 84%. This is 50%. So 70% is going to be somewhere right around in here. And we're going to sketch falling below it, means of course sketch below it. Okay. Now, that is 70% of the graph, right? That's what we're trying to do. So how do I go backwards then using my z-table for 70%? Well, 70% is equal to 0.7000. Well, and why is that important? Well, on the z-table, they go to 4 decimal places. Really, it's just 0.70, right? But 0.7000, well, let's get the number that's closest to that. And I'm not talking about on the outside. This is not a z-square. This is a percent. And remember, the percents are in the middle. So 0.7000. Look at, I can kind of follow it. I see 0.7 getting smaller. Oh, right here. It's between those two right here. And I'm going to tell you the answer is always the closest one. And so 0.05 or 0.52 is 15 away. 0.53 is 19 away. The one that's 15 away is closer. So 0.52 is the answer. The answer here, again, the point z is 0.52. That's what we're looking for, is the z value. Okay. The next one, the z with 85% falling above it. Okay, so again, we knew if this is 0, let's sketch this. That was a terrible curve. 1, 2, 3. At 1 is 84%. So 85% was going to be right next to 1, right? And falling above it, of course, means we got to sketch to the right because it's above it, right? So, is that right? With 85% above it. No, that's not right. 85% above it. This is not 85% of the graph. Well, this is 16%, right? Or 84% going this way. So it's actually right here. Right? So it's going to be just under -1. And it's going to be all of this. Now, does that make sense for 85% falling above it? Yeah. 85%. So, what is this percentile then? Right? Where 85% is over here, then 15% would be over here. Well, there you go. Back to 15%. 15% is 0.1500. So I go to my z-table and I look up which one is closest to that. Now, of course, it's not on this side. 1500. Let's see. 19215. Okay, so this is, sorry, you can't see that. Here you go. Negative 0.103 is 15 away. Negative 0.104 is 8 away. There's the one. It's the closer of the two. So negative 1.04. That is my z-score. Okay. So let's keep going here. The next one, it's presented a little differently, but it's not that difficult. Okay. We're talking about 0, 1, 2, and is less than, or excuse me, we're trying to find the number z such that the proportion of observations is less than z, less than z is 0.8. I can't talk right now. So 0.8, what does that mean? That means 0.8000. Similar to how the percents turn into decimals, this is just a decimal already. So where is that on the graph? Okay. And again, we're talking about 0.8. Let's go, when I go to look that up, 0.8000, let's go look it up here. In between these two right here. Okay, this is 0.84. That's only 5 away. Yeah, that's the winner. 0.84. And 0.84. Well, that's right here. Where of course it's 80% because this is 84%. So 80% would go there. And I was trying to purposely kind of not do it till later, but that's the way that this one is. Okay. All right. So one more here. Maybe try it on your own. Part D. And we've already seen a couple of problems similar to this. Number Z such that 90% are greater than Z. Maybe try it on your own, come back and check it out. 90% of all are greater than Z. So that means, again, it's going to be something here where this is 90% over here and 10% over here. Where does that fall? Well, one standard deviation is 16%. So 2 standard deviations, 3. It's going to be somewhere here, and I would shade in that direction there. Okay. So again, what is this? This is 0.1000 because 10%, right? 10% as a decimal, 0.1000. Go find that on my Z table. It's negative, obviously, down here, right? So negative 1 point something would give me at least an estimate. Look at my Z table, 0.1. It's like negative 1.28. That's only 3 away. That one is 15 away. Yep, it is. Negative 1.28. That is my Z score. Okay. So, there's that. There's not a whole lot more here. 12-minute video. That's not so bad. Okay. This actually is going to go faster than it looks because we already know how to do it. Okay, so here it's talking about the mean, 7.5, and the standard deviation of 1.5. So we have some things here where, again, and I'm going to stop showing the Z table every time here because it'll just be easier to keep going, and you can look it up yourself to check. Okay, we're going to draw the 60th percentile. Okay, remember again, this is 50%, this is 84%, so 60th percentile is going to be somewhere right around here. Okay, and it wants the score in the 60th percentile, so it's shaded down here unless it says above. Okay, 0.6000, when you look it up, is close to a Z-score of 0.25. It's the closest to. So when I do the Z-score, which means I'm going to plug this in right there for Z, right? So 0.25 goes there. The score, the value, well, it's to find the data value is my X here. And to solve this problem here, well, you just have to times both sides by what's in the denominator first to get those to cancel. When I times that by 1.5, I get 0.375 equals X minus 7.5. Well, how do I solve that? Well, you would just add 7.5 to both sides. Okay, so I get my answer, which is 7.875, which kind of makes sense. If the middle is 7.5 and this is 9, 7.875, yeah, that makes sense. It would be right about there, right? What is at the 25th percentile? Again, to go kind of quick here, this is 50, this is 16, so 25 is going to be somewhere right in there. When I look it up, it has a Z-score of negative 0.67. Of course it does, right? That's about right where I was thinking. Okay, that will go again in here. Okay, and X goes there. Times both sides by 0.15 to get X, or excuse me, to get negative 1.005 equals X minus 7.5. And then I would just add 7.5 to both sides to get X equals 6.495. And again, makes sense. This is 7.5. Going this way would be 6. Yeah, it's maybe a little bit shaded. Oh, sorry, I forgot to shade here. Should have shaded. Alright, the top 15% of all scores. Well, remember again, this is 84%. This is 90, what did we say earlier? 97.5. So the top 15, well, that's going to be right about there. Right, 1 point something, that's not going to be very big. We've actually kind of looked at a problem like this already, I think, if I remember correctly. The 15th percentile, because what we want, the top 15%, we want this. Okay, so what would be to the left of 15%? Well, that's pretty easy. That's 85%. that would be that part right there, right? The z-score for, again, for 0.8500 is 1.04. Okay, we actually did something like that. So plug it in. See how this is kind of repetitive, right? And that's that. Go through, multiply by 1.5, and add 7.5 to both sides to get 9.06 as my solution. Okay? Again, we said this was 9 just after it, 9.06. Yeah, that sure makes sense. Okay. Last problem here. Okay. On number 5, 40% fall between what two scores? So 40%, again, this is 16, this is 84. So for the top 40% would be 20% here, so maybe like right here, and 20% here. So it's going to be something like, probably could have do straighter lines, but something like this. The middle 40%, right? One standard deviation, remember, is 68%. So 40% is surely going to fall between that. Okay? So what are these markers then? This is, well, 40% going both directions means I'm splitting it into 20 and 20. So 20 this way means that that is the top 30%, right? 30 plus 20 gets me to the middle. 20 plus another 30 gets me in here. So if this distance is 30, then this number right here is 70%, right? 100 minus that gives me that 70%. Okay? Now, find the z-scores for the percents. Well, I look up 0.300, I get negative 0.52. And if you remember, its reflection is just 0.52, and I could have looked up 0.7000 and it would have been the same thing. That's between those two there. Okay. Then I've got, let's see, well, I've got to do this formula. I'm not going to show you how to work. It's this formula twice. I'd have negative 0.52 equals x minus 7.5 over 1.5, and then I would do, sorry, you can't see that. And then I would do positive as well, and I end up getting x to be 6.72 and 8.28. I'd have a positive here. When it moves it over, it would be greater. Which kind of makes sense. Again, we've said over and over, that's 9, so 8.28, yeah, that makes sense. That was 6, so this being 6.72, yeah, that makes sense too. Okay? Alright, so break this down into two things. Okay, this is the homework to maybe just try today. And then come back on Thursday and maybe try the practice quiz. Okay? On Friday, I will post the solutions for both, and then I will post a quiz that really looks a lot like this. What I will tell you though is if you go to the practice quiz, do not worry about number 3. Okay, matter of fact, that means that too. Because number 3, we're not doing a percentile problem. This is going to be just like, really, like this page of notes that we just got done with. It's going to be a lot like that. So do a practice, do a little bit on this third page. Again, these are posted, but I will kind of show you this again. There is no percentile. What is 75th percentile? Yeah, you can go through. You can try some of these problems. Okay, it's working you through it. Okay, walk your way through it. If you have questions, you can shoot me an email. Otherwise, try this and then check answers and try the practice quiz on Thursday. Friday quiz. Have a good one, guys. Next week we're gonna start something a little different. We'll get to that later. For now, do your thing.